When you want to adopt Kafka and you want to adopt ksqlDB, but there's some resistance inside your organization, what do? Well, Ruslan Gibayev, who's a data architect at European startup Bolt, faced exactly that problem. I talked to him about how he tackled it and really where he's got with that adoption effort up till now on today's episode of Streaming Audio, a podcast about Kafka, Confluent, and the cloud. Hello and welcome to another episode of Streaming Audio. I am your host, Tim Berglund, and I'm joined in the virtual studio, stretching over an entire ocean and the better part of two continents, by Ruslan Gibayev of Bolt. Ruslan, welcome to the show.
Hey, Tim. Thanks for having me here. Glad to be here with you.
Excellent. Hey, so tell us about what Bolt does and tell us about what you do there.
Sure. You may think of Bolt as the European competitor to Uber. Basically, we started in the ride-hailing space, but over the years gradually expanded to micromobility and food delivery as well. And right now, we are the leading micromobility platform across Europe and Africa.
Awesome. And what is your role there at Bolt?
I work as a data architect in data engineering department. Mostly I focus on the, two opposite sides of the world. One is being everything related to data warehousing technologies like ETLs, data lake, and so on. And the other one is everything related to real-time stream processing and real-time data.
All right, that's kind of what we want to talk about today. Specifically, what I want to focus on in terms of your story is how you drove Kafka adoption and ksqlDB adoption. That's a question that I get a lot from other developers who are thinking about event-driven architecture and new trends for the future and how to be in the right place in the future is, how do I convince my company to adopt this technology if they're not already into it? And you've got kind of a neat story there. Starts with change data capture, but it's not really a story about change data capture, but tell us about how you did that. What was your motivation and how did you start the process?
Yeah, that's a very good question, actually. So before joining Bolt, I did have a very good experience working with Apache Kafka, and I really liked it. I mean, I understood all the, how it makes the life of developers and in microservice world easier, and how it brings the power of real-time data to the company. And when I joined Bolt, at that moment, we were a grown-up startup, and we were growing real fast. And it means that at some point, we were in a state where we had all the different flavor of technologies, like some services working over the APIs, some services working over directly calling the DBs of our services. There were some messaging queues also in place, but I would say we were lacking some kind of standardization. And thinking a few years ahead of the time, I understood that, something has to change and we need to adopt Apache Kafka. And honestly, it took me some time to convince the people and make them believe in the technology. And that's exactly where we have the use case of change data capture coming into play. Because at some point, we realized that our data analytics platform is not very reliable. At that time, we had a process in place which right now usually people call the query-based CDC, which is actually a fancy name for a dump process which usually hammers your databases and polls them every 10, 15, whatever seconds. And this process had plenty of disadvantages. It was not very, reliable. There were duplicates. It was hard to maintain and so on. And the biggest problem was that, actually people didn't trust the numbers, because every second day something was wrong and some numbers were missing. And at that moment, I proposed to implement a new process, which is the log-based CDC or the bin log-based CDC. Basically, when, instead of polling the database, you can simply read the internal binary logs of the databases, convert them to messages, send them to Apache Kafka, and then do whatever you want with the data you have. We started with this project. It took us some time to migrate to this new pipeline, but I would say pretty instantly, people started trusting it because all the numbers were, precise. Everything was correct. Everything was real time. There was no delays. And it created the very good reputation for the Apache Kafka as a technology and all the other stack of technologies which we also adopted along the way, ksqlDB being one of them.
Oh, which we'll get into in a minute. Was that Kafka and Debezium? Did you use Debezium for the CDC?
Yeah. So heads up to all the guys from Debezium. They have, they did a really good job implementing all their Debezium connectors. Yes. So internally we run on MySQL, and when I started digging into this project, I found the Debezium project. I didn't know about it before, and I realized that that's exactly what we need. And luckily, Debezium was developed to be perfectly matching with Apache Kafka, and that kind of brought all the stack.
Yep. We've got a number of other episodes on CDC, and I think at least one on Debezium, so we'll make sure to link to those in the show notes. But again, I'm interested not so much in CDC because that's a known thing, but your adoption journey. So what was this is a solid use case to start a Kafka deployment inside a company. There are things happening here. We need them here. And hey, if they're inside a database, that's fine. There's Kafka Connect connectors that'll get them out, and we can get them to the other place. That's a great place to begin. It's easy to think about. It's like solving a known problem, and all that makes sense. But what was the resistance to Kafka to begin with? You described an adolescent or young adult startup with a bunch of different tech stacks and, the way life is, just different things everywhere. And you wanted to bring Kafka in because you'd had success with it. This was going to be a good thing. But why not? What was the pushback?
Well, I would imagine pretty much every time when someone wants to implement new technology, other people, and that's actually a good thing to do, other people would challenge this guy, simply asking why? Why do we need to adopt this technology? Why do we need to learn it? Why do we need to support it? And speaking of Apache Kafka, at that time, when we were starting this project, there was no cloud offering on the market yet. Confluent Cloud was not generally available to the public at that time, which meant that we have to run the infrastructure ourselves. And as you know, Kafka is highly available distributed system, which means usually you run it on more than one machine. And my colleagues started simply challenging me and asking, because surprisingly to me, none of them had previous experience with Kafka. And that was the first obstacle to tackle. And after that, it gradually propagates to other teams and higher across the hierarchy. And other people started challenging you. Why do we really need to adopt new technology? Because it will take some time. I started describing all the benefits, speaking about real-time data, about connecting all the silos, having the single central place which streams the data in real time, low latency, and being able to make the stream processing. And honestly, it didn't happen overnight, so it took some time for people to understand. And even better, I'm really glad that we had this use case because it allowed me to show them on the real example, how it works, what it does, what's the benefit, and what can we do more.
Yeah, and I guess with having to operate it on your own and not having a fully managed service like Confluent Cloud at the time, that was a pain. This message brought to you by Confluent Cloud. That would be a barrier, honestly, because there's a lot of operational lift there. But once you got over that and you got some buy-in and you had Kafka deployed and you had Debezium deployed, it seems like there's a natural evolution. And if you want, you can dig a little bit more into the use case. Like you said, before you were doing query-based CDC and the results were unreliable. Was this an
Yeah.
analytics thing? Was it some kind of reporting thing? You switched to log-based and it got better. So take us from there. You mentioned ksqlDB, so it seems like it's an analytics thing maybe, but
Yeah.
keep
So
taking us through your adoption journey.
cool. The initial use case was purely analytical. So basically, people wanted to get the data from OLTP databases and put them into some single place from multiple OLTP databases at the time. There were not that many of them, but more than one already, and put them in a single place where they could, query all the data, where they could join the data, where they can enrich it and calculate different stats. Because, like I said, we are working in a micromobility space, and usually people are interested in how many rides we had over the last week per every city we operate in, and so on. And we had plenty of such dashboards and also the reporting, like management reporting, investors reporting, for some kind of forecasting, and all the other analytical use cases. At that time, honestly, there were not that many of them, but still, the question was whether people can trust the data or not. And I realized that if we do this thing properly, we can get Kafka adopted, and this whole pipeline over the time will get much more adoption. Like all the other use cases will be built on top of that. We can switch the microservices communication to this pipeline. We can also do different kinds of stateful stream processing. We can do the anti-fraud, like fraud prevention. We can do the machine learning there. Like pretty much all the ETL-based jobs or any other workloads can be switched to real time. I mean, it's no brainer. It would be much better, right?
Absolutely. I mean, that's the goal, but you have to kind of persuade people one step at a time. So as you've got this OLAP pipeline, you're extracting OLTP data and you've got this OLAP pipeline. How did you think about how to do that real-time analysis? You said ksqlDB, but obviously there's Kafka Streams presents itself as an option there. Like, how did you work through that trade-off, and what did you end up building? I mean, what exists right now in ksqlDB?
Yeah, that's a very good question. And like I said, at that time, comparing to now, we didn't have that many, let's say, databases to replicate or even source tables to replicate, right? But to me, it was clear that if we assume Bolt keeps growing at the rate we had at that time, over the year, it will already transform into a huge number. And I realized, when we're talking about replicating the OLTP systems data to some kind of data lake or data warehouse, we have to also understand that you cannot simply replicate all the data. Some data is sensitive. You want to kind of anonymize it, maybe hide it. Maybe you want to not replicate some fields. Maybe you want to filter out some records, right? And it means that you have to do some kind of stream processing. And that made me think, all right, which options we have on the table? Obviously, like Kafka Streams is candidate zero. But what else we had? There were other frameworks like Apache Flink, Apache Spark, something else. But me personally, I wanted to stay native to Kafka ecosystem because I wanted to work, all the software, the closer it is to each other, the more native it is to each other, the better. And that's exactly when I started thinking about ksql. So honestly, I was considering between two candidates, Kafka Streams or the ksql. And imagine this. You have let's say 100 tables to replicate, and you want to have 100 stream processors, right? And you assume that over the maybe year or 2 year, this number can grow to 1,000 stream processors. And sometimes when we are talking about database CDC, you have to also think about database migrations because, sometimes people add new columns, they drop them, they change types, right? And it means if we are talking about strictly type pipeline, it means that you would also need to change your streams, right? And I mean, when I thought about, we know how Kafka streams work. You have to deploy your own apps and it runs inside of them. And when we think about having a need to, change 10, 20, 50, 100 such stream processors in Kafka Streams, it would be a pain. I mean, I would honestly rather kill myself than do that. And that's exactly where KSQL shines. Because in KSQL, what I really like, KSQL is like, I honestly believe it's a perfect fit for this use case. It is a declarative and it's easy to deploy. Basically, KSQL is like an engine. It runs your logic for yourself. You simply give it like config file with the queries and it runs them. And it's very easy to modify, change, add new queries, drop obsolete queries. So honestly, when I compared those two options, for me, it was a no-brainer. I decided to go with the KSQL.
That makes so much sense, and that's a great dimension. It's funny. That's a dimension that doesn't come up very often in the trade-off between ksqlDB and Kafka Streams when people are considering that. But in this kind of classical data pipeline use case, wow, yeah, I mean you're going to version 100 or 1,000 apps, which I mean you could get a different job before you kill yourself. But honestly, that's kind of the list of sort of rational next steps. I'm with you on that. And so, yeah, that brings ksqlDB to the top of the list.
Yeah, to add even more, when I was doing my investigation and research, even at that time, and even now, I honestly don't see that many use cases of KSQL. That many articles or companies saying that they use KSQL for this use case. But honestly, when we have already implemented it, while having that, I honestly think that, over the years, it will become like de facto canonical industry standard tool for this use case. Because like I said, it's so easy to use it and it does the job like extremely well. It has a bunch of advantages over the Kafka Streams. I have even written a blog post on Confluent blog where I have listed like all the advantages in my humble opinion. So I really believe that, that's a perfect tool for this job.
Tell us about serialization format and schema registry and that kind of thing. Were those a part of the pipeline? I mean, there was a serialization format. I mean, like, was it Avro? Was schema registry involved? Because you're talking about the key advantage being it's more resilient in the face of schema changes. So what did schema look like at a lower level here for you?
Yeah. When I started working on this project, I also realized that maybe a bit of the context. Internally, in Bolt, most of our backend applications run on TypeScript over the Node.js. And, don't get me wrong, it works perfectly well. It has like this language and this runtime has plenty of advantages. But it has also one small disadvantage, which is, it lacks type checks in runtime. And I understood it very well. And given at that time, I have just switched to data engineering, it was quite obvious to me that having like all the pipelines start to end strictly typed is a must. Because come on, how can you guarantee something or how can you rely on something if you cannot really impose the proper types? And that's why I realized that this whole pipeline, it has to be strictly typed. So we have to have some kind of format which guarantees the types. And God, how happy I was when I realized that KSQL is integrated, like seamlessly integrated with Schema Registry. I mean, come on, both of the technologies are developed by same company. It's not that you have to integrate it yourself. It works out of the box. And yes, at that time, Schema Registry was supporting only the Avro format, which for our use case was absolutely fine. I mean, we are still using it, even though Schema Registry got adoption of other formats as well. But Avro is perfectly good format for our use case. And so yes, we adopted, for this whole project, we adopted Kafka, Kafka Connect, Schema Registry, and ksqlDB. It was called KSQL at the time. And yeah, it works seamlessly well.
It's like chocolate and peanut butter plus marshmallows and graham crackers and a few other good things all together. that just taste better together. Each one individually good, but yeah, there's sort of a gestalt thing, where you have them all together. The whole is greater than the sum of its parts. One last question about schema changes, just out of curiosity. When they happened, of course they happened, did you ever did you find that you always had to, say, tear down the old KSQL query and create a new one? Or did you ever have schema changes that, due to schema registry and Avro, the old ksqlDB query still worked because it was only picking out certain fields and everything? What was the experience actually like of going through a schema change?
Yeah, that's a very good question. And first thing first, it was noticing that first of all, we had to become friends with DBAs because, like previously, I guess in many companies it works the same way. DBAs, they kind of they believe that they live separately in a separate world, that they protect their databases, and they can do whatever they want, like all the types of migrations anytime they want. But now we started relying on them. We started like depending on them because we had to react to any single schema change. And yes, you mentioned it correctly. There are some types of schema changes which are, let's say, not compatible. I mean, you have to restart the ksqlDB query. There are some, majority of them are compatible, like simply, let's say, adding new column or dropping some optional column. It's totally fine. But for example, if you change the type of the column, like let's say you want to extend from integer to big integer, in Java world and in KSQL world, those are two different types, right? And that's why you have to like internally create the new version of the schema and like redeploy your query, which I guess brings us to the topic of deploying the KSQL and managing all those queries. Like at that time, when we started, and even now, KSQL was supporting two modes of operating, right? The one called interactive and the other one called headless, right?
Yes.
And initially we started working with the in the interactive mode because I picked it because I like the name. It means that it is interactive, and you can simply input something and you see the results instantly. But and we had it running in production like for a few months, I would say. But then at some point I ran into the use case when, imagine a situation when like I said, for example, we change the type of the field in some table, right? But this specific column is used as a foreign key in 10 other tables, which means that when its type changes, you have to modify and restart the 11 queries altogether, right? And it means that in the interactive mode, first of all, I had to drop those 11 queries and recreate them. And I realized that, well, with all due respect, but this approach is not very scalable for our use case, because if I had like 50 or 100 such dependent tables, it would take a considerable amount of time. And we switched to the headless mode. And for this specific use case, in my opinion, it has plenty of advantages, like, for example, the workload isolation or the ease of redeploying the queries in the chunks, not by one, but in the groups. And we had like all the queries, we have them versioned under the version control system. And once someone changes them, right, we can simply have a CI which deploys the new file and restarts the KSQL engine.
Now, we're recording this on the first day of June 2021, and migrations, I think, about a month old in version 0.17 of ksqlDB. Has that been a thing you've been able to take a look at yet?
Yeah, that's true. Migrations were released in few prior versions of the ksqlDB. No, we didn't honestly have a chance to look into them yet, but like I said, so far we are quite happy with operating in a headless mode, because it allows us to, I agree, majority of the such changes and interactions implies only like small changes, maybe like one table or to two tables. But sometimes we indeed have to change queries in batches, like 5, 10, 15, 20. And for this use case, the headless mode is very, very nice, in my opinion. We will definitely evaluate the migrations, but so far, like I said, it's not really an urgent thing for us.
Right. Did they come out in 0.15, not 0.17? I'm just the host here. What would I know?
Yeah, I guess even prior to maybe 1.7.
Okay. All right. Because before I said 0.17, I was actually debating with myself whether it was 1.5 or 1.7. We'll find out, and we'll put a link in the show notes to the blog post. Last question. You mentioned, a future direction. You start with CDC and you end up with reactive microservices. How far along are you guys? How far have you been able to push Kafka adoption and really more broadly event-driven architecture inside Bolt?
Yeah, that's a very good question. And like I said, this whole picture, the broader picture, it was my dream to get it adopted in the company like 2 years ago. And right now, we won the trust of many other colleagues of mine. And I seen the pattern of different people from other teams coming to me and asking questions like, hey, do you think it would be better if we start building this whole new microservice straight away using the events we have? So to answer your question, we keep using it like we still happy users of the log-based CDC. After that time, our analytical platform has grown like 10 times. We have much more reports, dashboards, and people making the decisions on top of this data because, like I said, all of them trust it now. Also, we opened this data up to the backend microservices. We also started doing the stateful stream processing for different use cases like anti-fraud or machine learning stuff. And the main benefit is that, it's real time. So you don't have to wait, you don't have to operate with 24 hours old data. It's maximum 5-10 minutes stale, or I'm talking about extreme use case.
My guest today has been Ruslan Gibiev. Ruslan, thanks for being a part of Streaming Audio.
Thank you, Tim. It was a pleasure talking to you.
And there you have it. Thanks for listening to this episode. Now, some important details before you go. Streaming Audio is brought to you by Confluent Developer. That's developer.confluent.io, a website dedicated to helping you learn Kafka, Confluent, and everything in the broader event streaming ecosystem. We've got free video courses, a library of event-driven architecture design patterns, executable tutorials covering ksqlDB, Kafka Streams, and core Kafka APIs. There's even an index of episodes of this podcast. So if you take a course on Confluent Developer, you'll have the chance to use Confluent Cloud. When you sign up, use the code PODCAST100 to get an extra $100 of free Confluent Cloud usage. Anyway, as always, I hope this podcast was helpful to you. If you want to discuss it or ask a question, you can always reach out to me at tlberglund on Twitter. That's TLBERGLUND. Or you can leave a comment on the YouTube video if you're watching and not just listening, or reach out in our community Slack or forum. Both are linked in the show notes. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover us, which we think is a good thing. So, thanks for your support, and we'll see you next time.